Assalamualaikum warahmatullahi wabarakatuh. I'm stand here is to explain you about the Internet of Medical Things or IoT, this is heart rate and body temperature monitoring system. Before I explain you about my topic, let me introducing myself. My name is Jansen Cristantio Erlando and I'm from Instrumentation Engineering. Right now I want to explain you with the table of content is first introduction, second system design, and third discussion, and last but not least conclusion. Human health is crucial, and monitoring vital signs like heart rate and body temperature is essential for early prevention. Indonesia healthcare system faces a challenge due to a growing population and the pandemic. To address this, IoT-based health monitoring has emerged, known as the Internet of Medical Things or IoT. Researchers have explored remote health monitoring system using IoT and device like a Raspberry Pi. In this research, an IoT-based system was developed using Raspberry Pi to monitor heart rate and body temperature in real time, aiming to accelerate disease diagnosis and reduce healthcare costs. What is IoT? IoT technology has been widely applied in various healthcare industry sectors, commonly known as the Internet of Medical Things. IoT is an intelligent platform consisting of a sensor and electronic device used to obtain biomedical signal from patient. The device consists of processor for processing biomedical signals, network device for transmitting biomedical data over the network, temporary or permanent storage units, and visualization platforms with artificial intelligence, same for decision making or diagnosis by doctor. IoT-based remote health monitoring system is an alternative that several researchers are currently developing to improve the healthcare system in hospitals. System design. First, sensor calibration. In this study, the heart rate and body temperature sensor will calibrate to reduce the measurement error value for each sensor. The heart rate sensor calibration process is carried out by comparing the result of the heart rate calculation using a pulse heart rate sensor placed on the finger with a comparison tool in the form of a pulse oximeter, measured simultaneously. The heart rate sensor calibration data retrieval was carried out for 5 minutes with a measurement time delay of 3 seconds so that the data obtained was 100 data. At the same time, the temperature sensor calibration process is carried out by comparing the result of the temperature calculation using the DS18B20 temperature sensor with a comparison tool in the form of a thermometer. Web server design. Several programming languages are used in making a web server, such as Hypertext Markup Language or HTML, Cascading Style Sheets or CSS, JavaScript, and database. Applications on the web are divided into static and dynamic web applications. HTML is used to create a static website, JavaScript to create a dynamic website, CSS to adjust the website appearance to make it look attractive and structured. The database used is MySQL, which acts as central storage for sensor measurement data obtained before being sent to the web server. The process of sending sensor measurement data to the web server uses two-way communication with JavaScript object nation or JSON data format. And the web server dashboard display use one-way communication by applying server-side event rules. The web server workflow is shown in Figure 3. System testing and measurement. System testing is done after system design and web server creation. This test is carried out to see the success of the system mesh. Testing the heart rate sensor and body temperature sensor begins with the preparation of measurement instruments and verification of the Arduino IDE. Program for further testing. The first test is the heart rate sensor, which is done by placing the sensor on one figure tip. After that, whether the sensor can record heart rate data and display the value of a beat per minute or BPM on the web server is observed. Fingertip selection and placement of sensor result in more consistent and stable data. Heart rate data varies according to patient condition and measurement. The second test is the DS18B20 temperature sensor, heart rate, BPM time, graph of comparison of heart rate measurement result, pulse, heart rate sensor oximeter, which is carried out by placing the sensor in the armpit and observing change in the temperature on the web server in degrees Celsius. Body temperature data will vary according to the patient's physical condition and the ambient temperature at data collection. Discussion. Sensor calibration result. In this graph, above show the result of measuring heart rate in one respondent, who is 23 years old. Heart rate measurement were carried out in the resting condition with a measurement time of 5 minutes and delay of 3 seconds. The test result show the heart rate is at 70 BPM to 74 BPM with an error rate of 1.41%. A normal heart rate press is in the range of 60 BPM until 100 BPM. Sensor calibration result of the temperature sensor. The graph above shows the result of the temperature measurement using the DS18B20 temperature sensor with a compression tool in a thermometer. The measurement result obtained an error rate of 1.09% from the measurement range 1 degree Celsius to 100 degrees Celsius. Next, system test result. The Internet of Medical Things, or IoT, beside heart rate and body temperature monitoring system has worked well. The result of heart rate and body temperature measurement are stored in database and then displayed on a web server in the form of graphs or tables. System test result. This is the display of data on a web server and heart rate, also body temperature. So this is the last of my explanation, the conclusion. Research on the Internet of Medical Things, or IoT, beside all heart rate and body temperature monitoring system has been successfully conducted. This system can monitor heart rate and body temperature remotely by displaying measurement data on a web server. The sensor calibration result show the pulse heart rate sensor error rate is 1.41% and the DS18B20 temperature sensor is 1.09%. After calibration of the sensor, data was collected on the 3 respondent heart rate and body temperature. The measurement result show the system can store each respondent heart rate and body temperature data in the database and display the measurement result on the web server in real time. Based on the dash result indicate the system that has been made can work well. So this is my explanation. Sorry if I have a mistake in the spelling and explanation. Thank you and Assalamualaikum warahmatullahi wabarakatuh.